so we can judge you accordingly, because after the conference end, we will have like a best presenter award, so we will need to judge accordingly. Okay, I think the first presenter is already here, so we would like to start the session immediately. The first presenter is Admiral Musa Julius, with the title of the presentation, Run-Up Measurements to Coastal Villages Due to the 2011 Earthquake-Generated Tsunami in Jayapura, Indonesia. If you are ready, you can start presenting your presentation, and we will start the time immediately.
Yes, thank you, moderator. Can you hear my voice?
Yes, it's very clear.
Okay, thank you. I'm student, so because I need to clarify this, I'm a student. Thank you, moderator, for introducing me, and this morning I'm glad that I can attend and present one of my abstract with our team. Now I would like to open my screen. Sorry. Okay. Let me try to open my screen. Okay, this is not open. Since coastal settlements, summary and reflection. In the first slide, I would like to recall of the earthquake that happened in 2011, that is 15 years ago in Japan. The Tohoku earthquake was really big, magnitude 9, the second magnitude 9 after the Indian Ocean tsunami, that occurred in the offshore of the Honshu Islands of Japan. It was occurred at 2:46 p.m. local time in Japan time, or Indonesia is in the Eastern Indonesia time. The earthquake that happened in the Pacific, so the Pacific Tsunami Warning Center, which is responsible to tsunami warning in the Pacific countries. So Pacific Tsunami Warning Center issued tsunami warning, as well as Indonesia, which is member states of the Pacific coastal member states, also forwarding this tsunami warning message to area which is vulnerable, that is northeastern Indonesia, which is Sulawesi, Molucca, and Papua. Then after that, the bulletin of the message also consisting of the estimation of tsunami heights. The tsunami estimation was 0.5 meter to all of the northeastern Indonesia coastal. So it is the yellow mark of all of the coastlines in the northeastern. And as tsunami bulletins do, at the period of 3, the tide gauge is the confirmation that tsunami has been recorded in the several coasts. The wave amplitude ranking was very variable, from the 0.07 meter to 0.85 meter. So it's vary of the tsunami wave recorded in the northeastern Indonesia. I would like to show the tsunami model, which is generated by Tohoku University in 2011. We see that this earthquake also propagated to the another coastal states in the America and in Southeast Asia, which is Philippines, Indonesia, USA, Chile, and so on. We know that the Tohoku earthquake also generated the trans-Pacific tsunami that propagate for not only minutes in Japan but also hours to the another coastal states. For Indonesia, the status is watch or 0.5 meter potential. The tsunami happened in Japan is near-field tsunami. Everybody know that the tsunami is very devastating the coastal of the east coast of Honshu and also affected to the Daiichi nuclear site. And this is what I will emphasize, that tsunami also recorded in the another equipments in the far area, in the far field area, like in the dark buoy and tide gauge in another coastal states. This picture illustrating the far field tsunami reached the dark buoy sensor and tide gauge sensor in some islands, that in Hawaii, in Marquesas, and also in Indonesia. Another thing that we also can capture beside of the equipments, we can also see from the mobile phone camera that catch the picture from Marquesas, Pacific, Chile, Crescent City, California, and Kona, Hawaii, which also affected to the 2011 tsunami. This is the distribution of the heights, map of the tsunami heights distribution in the Hawaii Islands, also in Kona, that is also vary from 2 meters to 5 meters. In this slide, I would like to highlight the tsunami warning bulletin from the first to the fourth that providing by BMKG that we are servicing to the Indonesia Tsunami Early Warning System from the bulletin first until bulletin 4. That in Indonesia we have a standard that the bulletin first is for the earthquake parameters. The second bulletin is about the updating the earthquake parameters with the tsunami potentials. The third bulletin is about the confirmation of the tsunami has been recorded, and the fourth is about the tsunami warning cancellation. At the time, we're waiting for some hours before we cancel or we end the tsunami warning. And this is the tide-based monitoring recap. The observed height from Molucca, Papua, Sulawesi, and also the other islands. We know that it's also vary. In Jayapura, I will emphasize this, that it's almost 1 meter, 0.85 meter. That the distance from Japan is 4,300 kilometers. And it's arrived at 11:35 UTC. It means in Papua or in local time, it will be 8:35 Eastern Indonesia time. And then this is the distribution of the tide gauge along the northeastern Indonesia. Means these are the tide gauge which recording the tsunami from Japan. Okay, these slides also I will emphasize this, that a few days after the 11 March of 2011, the tsunami survey team, which is formed by international tsunami survey team from Indonesia and from USA, BMKG and another team also make a survey team. They formed a few days, and we found that some of the tsunami gauge in the coastal is different to the tide gauge or different to the estimation before. Then we found that there is a 2.8 meter tsunami in the Holtecam housing in the number second.
1 minute left.
Oh, okay. This is the tide gauge record. Okay, this is I captured this from the Sapulama et al. This is the tsunami risk in Jayapura, in the English village, which is one of the village in the Yotefa Bay, which is affected to the tsunami. This is not affected by an earthquake, but this is affected by tsunami. This one in Yosudarso Bay. Jayapura is unique. We have two bays there. There is Yotefa Bay and Yosudarso Bay. In the whole Tekam, there is damage in the coast, and this coast also affected to one victims or one fatality here. Then this is the wider picture of the bay, that is Tanah Bay in Jayapura Regency, and Yosudarso Bay and Yotefa Bay in the Jayapura city. As the summary, we conclude from this study that the distant tsunami is also prone to Indonesia, not only the near field tsunami. And this makes a bit confusing because no damage because of the earthquake, but the tsunami came with the hydrodynamic force. Then the base shape also affect to the amplified to the tsunami. Even the gets measure less than 1 meter, but in the fact the tsunami can reach to more than 1 meter. Then the human infrastructure impact. Then yeah, the last slide. This is the last slide that we have to consider to the damage not only by the earthquake but also the only tsunami that is from Papua. Thank you very much.
Okay. Do the participants in this online session have any questions? Okay. In that case, I have questions to the presenter. So the impact of like the 2011 earthquake tsunami in Jayapura came from the earthquake in Tohoku-Japan, right?
Yes.
As you shown before in the interactive animation, there's like quite some time regarding like the time lag of like the impact of like the tsunami generated wave until it reaches Jayapura. I just want to ask, like, even though there's like a time lag, there should be like an early warning system implemented by the Indonesian government regarding like the tsunami estimates, and it shows that the level is I think waspada, right?
Yes.
How does the impact of like the tsunami is reflected, even though there's already a warning system at that time? Does like the population that are affected are minimum? Because you show in your presentation previously, there's like 2 coastal villages that are severely impacted by the tsunami, right? Does like the early warning system reduce the minimum of casualties, or it doesn't affect at all due to the maybe poor disaster preparedness or poor disaster knowledge in that region? Thank you.
Okay. That's a very good question. In my opinion, at the time, 2011, our coastal community in the northeast Indonesia were not really ready to the tsunami because it's very long time away from the 1964. It's the last part of the tsunami. Can you imagine 50 years gap between Alaska tsunami 1964, which affected the Jayapura coast? So they are not really well prepared. And then our tsunami early warning system just developed for 3 years after the first inauguration in 2008. So the coastal community, exactly in the rural area in the Jayapura city, they are not well informed about the products of the tsunami early warning system. So at the time, the local disaster management office were struggling, work hard to make understanding. Luckily or fortunately, the tsunami came 5 hours after the earthquake, so they have more time to evacuate people. However, why there is one people one person died, it's because he was boring after 5 hours. He decided himself to go to the his house to take some of the things in the house, but another people already in the higher ground to wait until the tsunami warning ending or tsunami already or all is clear or safe. Thank you.
Okay, thank you for your answer. And thank you for your insightful presentation. I hope your research goes well in the future as well. Okay, now we move on to the next presenter. The next presentation is titled Capability Enhancement of People with Disability in Managing Disaster Risk. The presenter is Tiffany Savika Dewi. If you are ready, please share your screen and please notify if you are a student or non-student before the presentation starts. We will start the time after you start presenting your presentation. Miss Tiffany, are you here?
Yes, I'm here.
Yes, I'm here.
Let me share my
Let me share
screen.
my screen.